Chemical engineers use math to solve real problems. Lecture 1 of CHEG210 shows how the integrating factor method cracks open differential equations.
Let's dive in.
Separable method. Separable is simply direct integration if you can separate them into y and x and you solve them. We'll talk about this later this week. The other way you can solve them is using the integrating factor method. Now, integrating factor method simply means you multiply the differential equation by an integrating factor u of x to convert them into a differential equation that you can solve by direct integration. That's what it means. The other method is we could do exact differential equation. Of course, this has a special conditions, which we're going to talk about next week. And then we could also use the Laplace transform. There are also other methods. Laplace transform, later as the semester go on, we'll talk about that. And we also have the Bernoulli's equation. So there are several ways we could solve it, but these are the 5 most important ones we're going to talk about as this semester go on. But today, all we're going to talk about today is integrating factor method. And then, in what case is integrating factor applicable? If you have a differential equation, first order linear differential equation in this form, and then you cannot solve them by direct integration, like the examples in your workbook. If direct integration is not applicable, we use integrating factor. What integrating factor simply means is you multiply the differential equations by u of x. U of x is known as an integrating factor to make it easy to solve. Now, how do we find that u of x? I'm going to derive the formula for you, but all you need to know is the formula. So let's assume we have dy dx, like I said, plus p of xy is q of x. Let's multiply by integrating factor. If we multiply by integrating factor, it becomes dy dx multiplied by q, u of x is our integrating factor, excuse me, multiplied by u of x, right? Plus p of xy multiplied by u of x is q of x multiplied by u of x. Let's see. Now, let's do something interesting. Let me ask you a question. If you have something like this, dy over dx of, say, u of x multiplied by y, let's use product rule. Assume you have something like this and you want to do differentiation of this. Remember, the product rule is the same thing as saying u of x dy dx plus y multiplied by du of x over dx. Do you agree with me? That's a product. The product rule is, assuming you have these two products, what you need to do is keep this constant, differentiate y, dy dx. Keep y constant, differentiate ux, du of x dx. Now, if you relate this guy to this guy, because what we're trying to say, we're saying everything here is the same thing as, if you relate this to this, we can say dy dx u of x plus p of x y u of x, let's say it's the same thing as u of x dy dx plus y du of x over dx. Something can cancel out. What cancels out here? Let's see. These two are the same, right? Am I right? They're the same. If they are the same, it means everything here is the same as everything here. We're trying to find the integrating factor. That's what we're doing. So if that's the case, we have y u of x dx is the same thing as p of x y u of x. Y can cancel y. Why? Any question? Question? If you're lost, let me know. What we're looking for is u of x, remember. There's d here. It's missing d. Yeah. So let's bring u of x here and let's bring. So we have du of x over u of x is p of x dx. That's this come here. So let's integrate this. If you integrate du of x over u of x, what do we get? Does anyone know what we get? If you integrate the u of x over u of x, what do you get?
ln of x.
Thank you. You get ln u of x is integral p of x dx. So now, if you take the exponential of those sides, it becomes exponential ln u of x is exponential integral p of x dx. Now, exponential ln is the same thing as your u of x is exponential integral p of x dx. Do not forget this formula. This is how you find your integrating factor. You will use this a lot. You typically don't need to memorize how to derive this, but if you know how to derive this, it's going to help you a lot. So, if we are solving differential equation by integrating factor, the first thing we need to do is we need to find our integrating factor. And the formula to find our integrating factor, u of x, is equals to exponential integral p of x dx. That's the formula to find our integrating factor. And this is how we got it. Now let's solve the differential equation. The step 1 is find the integrating factor using this method. Step 2 is we solve the differential equation. Now remember that we already said that everything here is equals to this, is equals to this, and is equals to this. That's what we assume. We assume that the u of x over y is the same as this, and is the same as this because we equated it here, remember, and is the same as this. So if that's the case, we can also say this guy is the same as this guy to be able to solve for y because this has y. We could say that because now we find u of x, let's solve it. So we could say d over the x, u of xy, is equals to q of x, u of x. Now we're looking for y, which is the solution to the differential equation. So all we need to do is, we could just move this to this side. It becomes d u of xy is q of x, u of x dx. So if we do direct integration of both sides, if you integrate du of xy, d goes away, becomes u of xy. This one becomes integral q of x, u of x dx. Right? So y is our solution, which is what we're looking for. Our y becomes integral q of x, u of x dx divided by u of x. So this is our solution to the differential equation. So these are the two formulas you need to know. So to solve differential equations by integrating factor, there are two things. Number one is you need to find the integrating factor. This is the formula to find the integrating factor. And number two is you need to solve the differential equation, which is y is the solution. This is the solution to the differential equation. I could go back and explain it if you don't understand, actually. If you want me to go back, I can. Question. Of them by integrating factor. Number one is find the integrating factor. And to find the integrating factor, this is the formula. And number two is solve. To solve, this is the. Let's do one example. This is the shortcut method. Let's go to part A, question 1. So I'll solve question 1, and then you all will try question 2, 3, and 4. I'll go around and see. Please try it yourself. I'll solve it using this approach so that you all understand it. So there are only two steps. The first step is find the integrating factor. The second step is solve using the integrating factor. So let's do question 1. Question 1, we're told that y prime plus 3y is t plus e minus 2t. So there are two steps. Step 1, find the integrating factor. Our formula for integrating factor is this. And you do not need to memorize this. I would always give you the formula anyways. Our integrating factor u of x is the same thing as, this time around we're using t, so we can say u of t because it's t here that we're using, not x. In exponential integral p of t dt. If it's x, we change it to x. So what that means is, first of all, this you have y prime plus 3y is t plus e minus 2t. So remember that for a differential equation, first order linear, the general equation is dy dx or dy dt depending, plus p of ty is q or t of q or q of x if you're using x. So you compare this to this. So you compare P of Ty to this. So you say P of Ty is 3y because this second you compare, right? Y cancel y, so our P of T is 3. You compare this one. Then the final one is our Q of T is T plus exponential minus 2t. So we find our P of T, we find our Q of T. Now let's put it into this formula to find the integrating factor. So our integrating factor is U of T is exponential integral P of T dt. That would be exponential integral. Our P of T here is 3. Integral 3 dt. So if you integrate 3, you get what? 3t, right? So that would be exponential 3t. So our U of T is our exponential 3t, which is our integrating factor. We found our integrating factor. Now let's solve. The solution is just this one here. So our y, the solution is given as integral Q of T, U of T, is that U of T?
Yeah, U of T.
Okay, thank you.
Yeah, U of T dt.
U of T dt divided by U of T.
U of T, yeah.
That is our solution. Okay, so let's put it there. It becomes y is integral, our Q of T, we found our Q of T here. Our Q of T is T plus exponential minus 2t. That's T plus E minus 2t multiplied by E 3t dt divided by E 3t. If I missed a step, please tell me. Okay, so this becomes, y is, if you multiply this, it becomes integral T exponential 3t plus exponential T divided by E 3t. Right? The way I got that is this multiplied by this is this guy here, right? And this multiplied by this will be 3t plus minus 2t, right? That's 3t minus 2t, that's t. Now let's go back to our integral table. Let's split this. If you split this, it's the same thing as saying integral t exponential 3t plus integral exponential t divided by E3t divided by E3t. Do you agree with me?
Yeah.
Okay. Now, you go to the integral table and do this for me. If you go to the integral table, look for the one that has x exponential nx or something. There's several ways you can do that. So if you go to this integral table, you all have this table, right? Look for the one that has exponential. Integral of exponential is what you want to look for. If you find it, let me know. If you go to number 58, it's number 58. 57 or 58, you will see it. 53 is the appropriate one. Yeah, thank you. So it's 53. Thank you. 53 says that when you have integral x exponential ax dx is x over a minus 1 over a squared exponential ax. That's what 53 says. Is that the most appropriate one? Yes. So in this case, we have t exponential 3t. So our integral t exponential 3t becomes the t. Becomes x over a. In this case, our x is 3. So it becomes t over our a is 3. T over 3 minus 1 over a squared is 3 squared. Then exponential 3t. Did you get what I did here? Yeah. It's this table, 53, number 53 in this table. So that is this. Integral exponential t is exponential t. Am I right? Integral exponential t is exponential t. So we have this now and this. So let's put everything together. If we put everything together, it becomes t over 3. You still have this exponential 3t minus 1 over 9 exponential 3t, then multiply by this exponential 3t here, plus, that's for everything here, plus exponential t over exponential 3t, that's this guy here. Okay, so that gives us t over 3, because this cancels out this, minus 1 over 9, plus, of course, let's add plus c, the constant, plus exponential t over exponential 3t, plus c. Typically, plus c, let's leave this. Did anyone get this correctly? Okay, great. I'll let you write. If you want to. Yes, Nina.
Why don't you have to divide c by e?
Exponential minus 3t. Yes, you could do that.
Okay.
You're right. Because this c is a constant, you could have exponential minus 3t. Or you could just say plus c, where c can be equals to a exponential minus 3t. I do that a lot. Yeah, that should go with it also. You're right. Minus 1 over 9 plus exponential t over exponential 3t plus say a exponential minus 3t, where or plus c, anyone you want to use, right? Now, as t approach infinity, what happens? Does anyone know what happens as t approach infinity? Actually, we could simplify this to exponential minus 2t, right? Do you agree? Because this is 1 minus 3t, which is minus 2t. So when t approach infinity, what happens? Does anyone know?
The first term will become 0.
Which one? Okay, let's start with minus 3 times, let's say t is infinity. It means it's going to be very large, right?
Yeah.
Say 1 million values. What is exponential minus a very, very large value? Does anyone know? Anyone? Yes?
0.
0, yes. Exponential negative a number becomes so large that it goes to 0. That's what it means, right? So this term will go to 0 because, and that makes sense because if you look at it, exponential minus 3t is the same thing as 1 over exponential 3t, right? So let's say this number is 1 million. 1 over exponential 1 million times 3 is ridiculously large, that it goes to 0. That's what it means. This goes to 0. This goes to 0, right? This t over 3 becomes so large that no matter what, it's still going to be t over 3 because 1 over 9 is small. So what that means is, as t approach infinity, while we approach t over 3. That's what it means. Because it will be so large as t becomes large that this 1 over 9 would be negligible. That's what it means. So as t approach infinity, y approaches t over 3. Because this term is 0, this is 0, this becomes so large that even if you subtract 1 over 9, it still will become t over 3, no matter how large it is. So I will go around. I really, really want you to try question 2 yourself. If you don't understand, I'll come to you. The only way you can learn how to do this is try it yourself. If you get stuck, I'll come to you. Question 2.
Sir, exponent of infinity is 0?
Exponential negative infinity is 0. Not exponential
Okay.
infinity. Negative infinity.
Okay.
Because it's 1 over exponential infinity, which will be 1 over something that's so large.
So large, so it becomes 0. Okay,
Yeah.
okay.
So try question 2 yourself. It's just 2 steps. Step 1, find the integrating factor. Step 2, use the formula here to solve it.
Cube over 3e to the 2t.
Like this?
Yeah.
Plus
Plus c.
c e 2t. Please always add this. Always add this to it. C divided by e to t. Is it like this? Right? So it will be c e to t. Who got this? If you get this same answer, put up your hands. Does anyone get something that looks like this? if you get something different, let's see. Okay, let's solve it together. I know if you've solved it before, that's great. You can keep solving as many as possible there. The more you practice, the more you... But if you've not, let's solve it together. I understand that when it comes to math, some of us are extremely smart or not smart. Some of us have taken lots of fundamental math. So, some people are not. So, don't get pissed off if I solve a question you know you can solve, right? That's why I gave you tons of questions. You can just start solving the other questions. Sometimes I might be very slow and some of you might get very, very mad at me. Please bear with me. So we have y prime minus 2y is t squared exponential 2t. Or you can just listen to me and correct me if I make mistakes. Because I always do. So we relate this to dy dx plus p of, we're using t this time, let's use dy dt. P of ty is q of t. So if we do that, it means everything here is this, everything here is this. That's what it means, right? So it means our p of ty is negative 2y. Our y can eliminate y, so our p of t is negative 2. It also means our q of t is t squared exponential 2t. That's what it means. So if that's the case, we just need to know that our integrating factor u of t is exponential integral p of t dt. This is our integrating factor. So our u of t becomes exponential integral. We get our p of t is negative 2 dt. That is exponential negative 2t. This is the first step. Then our solution y u of t is integral q of t u of t dt. Right? Did I miss anything? Yes, that's it. So y u of t becomes integral q of t is this guy here. T squared e2t multiplied by u of t is e negative 2t dt. So that becomes y u of t is the same thing as integral t squared dt. That will give us, this one is straight integration. That will be t cubed over 3 plus c. So y u of t is t cubed over 3 plus c. So our y becomes, we divide it by, we know our u of t as e negative 2t, excuse me. We know that already, right? So y becomes, if you divide through by this, it becomes t cubed e2t over 3 plus c e2t. Yeah, that is correct there. That's correct. Now, if t approaches infinity, can someone tell me what happens if t approaches infinity? So then, yes?
Everything goes to infinity.
Everything goes to infinity, yes, because they become ridiculously large, right? This is large, everything goes to infinity. That's correct. Thank you. So let's jump a little bit. We'll come back. We have to solve all questions 1 to 12, and they are all exercise questions from the textbook. I usually just... So it means we have to get rid of these two. That's the first step. Because our general formula for a first order linear differential equations is dy dt or dy dx plus p of ty is q of t. There is no coefficient behind this derivative. So it means we have to say y prime over 2 plus y over 2 is 3t over 2. So we can cancel this out now. So we have y prime plus y over 2 is 3t over 2. Now, so what that means is if we equate this to this formula, our p of t is 1 over 2, right? Then our q of t is 3t over 2. So we have everything we need to solve this now. And if you've solved this and you feel like I missed a step, please let me know. If I remember, next week is your first test, week 3. If you check this syllabus, test 1 is week 3. So remember, I don't mean to scare you, but you're not going to get questions you've done before. You get completely different questions. But if I give you a question to solve in integrating factor, please do it this way in terms of, you have to show me how you got your P of t and Q of t. Don't just move from here and tell me P of t is this. I grade according to steps, so you have to explain to me as if I don't know anything. Please remember that. Then, once you get this, you can then tell me that your integrating factor U of t is exponential integral P of t dt. Okay, so what that means is it becomes exponential integral P of t is 1 over 2 dt. That will give us exponential 1 over 2t. That's U of t. Did anyone get it up to this point? Great. So our y, which is the solution to the differential equation, is, let's say y U of t is integral Q of t is 3t over 2, 3t over 2 multiplied by U of t is e 1 over 2t dt. That's what it gives us. So from here onwards, it's just direct integration. From here, it becomes our y U of t is, you can bring the 3 over 2 out because it's a constant. 3 over 2 t e 1 over 2 t dt. So we can use, is it number 53? Let's see. Does anyone know what number it is that we can use to integrate this? Anyone? Those of you that have done it, what number is it? 53 of our derivative table. So number 53 says that if you have integral x dx is the same as x over a minus 1 over a square exponential ax. So this time around, you have t exponential after it becomes x over a. Our x is t, that is t over, our a is 1 over 2, minus 1 over a square. Then you have exponential 1 over 2t. That's what it gives us. Using number 53. Using this formula, which is number, this formula means that our t is our x. Our a is 1 over 2. Right? No, this is wrong. It's wrong, definitely. Right? Oh, it's correct.
Yeah, it's right, sir. A is 1 by 2.
This was the one confusing me.
E. Yeah.
You should have told me. Okay. For a minute, I thought I was wrong. So this gives 2t minus 4 e 1 over 2t, right? That's plus c. Y ut is e 1 over 2t. So our y becomes 2t minus 4 plus c e negative 1 over 2t. Does anyone get it up to this point? Did anyone get it up to that point? Okay, great. So if you got it up to this point, you're right, because this guy cancels this guy, and this guy comes here to become negative. That's what I did. So what happens if t gets to infinity? Yes, Mora.
You don't have to quantify the 3 over 2. Like you took the 3 out of the 2 out of the integral.
Thank you. Thank you very much. You're right. So you're paying attention. I thought you're not. Okay. So I missed the 3 over 2. No offense. Okay, thanks. You see, if you pay attention, you will know if I make mistake. Whatever, you can multiply that. 3 over 2 multiplied by this, we already give 6 anyways, right? And this one, let's bring it out. So that one gives us, let me write it here so you can see it. So that one gives, our y is, that one gives 3 minus 6 plus c exponential negative 1 over 2t. Is that the final answer you got? Okay, thanks, Mora.
Sir, 4. It's 4. It's 4 cross 3, 12.
Yeah, 12 divided by 2 is 6. It's 3 over 2.
Okay.
Yes, I want to believe I haven't done, yes, because this 3 over 2 is outside.
Okay.
So when t approach infinity, what happens to the solution? What would the solution be when t approach infinity? Does anyone know? Anyone has an idea? If t approach infinity, for those of you that have solved it, what happens? Yes, you're raising up your hand. Infinity? It could be infinity or 3t, because if you look at it, this gets to 0, right? And this becomes ridiculously large. So large, yeah.
Wait, isn't it c e to the 1/2 t? Not negative?
But this one,
Like in the c term.
yeah. What do you mean?
Is there a negative sign in front of that?
Yes.
Yeah, it should be
How do you
negative.
get
Yeah.
that?
Why is the negative?
Yeah.
You have y here, y exponential negative half. If you divide c by that,
And then
it
go-
goes up.
Yeah.
Is c over exponential half, is c exponential negative half. But that's a good question. No, if you don't understand, you ask questions. Right? Math could be sometimes confusing. By the way, I teach only one class this semester. What does that mean? You can always stop by my office anytime. So this one approach infinity or 3t, the solutions will actually be 3t because this will be 0. And this one will be so large that even if you take away 6, it doesn't matter. So it approach infinity like that. Question. Question 11 is what you want to do next now. Question 11. Amy, do you have a question? P of t. So our p of ty is the same thing as y, which is this guy, right? So that means our p of t is 1. Okay. So our q of t would be everything here, which is 5 sine 2t. Great. So our integrating factor u of t is simply exponential integral p of t dt. That's it. So if we do it that way, it becomes, our u of t becomes exponential integral. Our p of t is 1. 1 dt, that's exponential t. That's it. And then our solution is y u of t is integral q of t u of t dt. So y multiplied by our u of t is exponential t is integral. Our q of t is 5 sine 2t, right? Multiplied by exponential t dt. Okay, so we can bring 5 out. So we have y exponential t is 5 integral sine 2t exponential t dt. Somebody please help me out. What number did you use for those of you that have done it? Where is the table? The table is gone.
83.
What number did you use?
105.
105. You're raising up your hand. 105? Okay, let's see 105. Is it 105? Are you sure?
Yes.
That's long. Okay.
What do you mean it's one? Do you have a different tape?
Oh no. I actually don't. By the way, I knew of some people that will teach this class and tell you should know this integration without using table. Right? Yeah. Okay. So I gave table because I don't want to stress you. Right? Because if you do calculus, you're expected to remember this, right? Anyways, 105 says integral exponential bx sine ax dx is 1 over a squared plus b squared exponential bx sine ax minus a cos ax. That's what it says. Is this the one? You tell me if I'm right or wrong. Okay, so if that's the case, we have exponential t. What we have is integral exponential t sine 2t dt. That's what we have. So following this is 1 over a squared. What that means is our a is 2, right? Our b is 1. That's what it means because bx is t here. So b is 1, 2t is ax, a is 2. So 1 over 2 square plus 1 square exponential bx, exponential t, bt. Sine ax is 2t minus a is 2 cos 2t. Then we put our plus c. So that gives us 1 over 5. Let's not forget that we still have this 5 hanging out somewhere here. Let's not forget. So let's put this 5 here. Right? Exponential t sine 2t minus 2 cos 2t plus c. So this guy can get rid of this guy. So we have exponential t sine 2t minus 2 cos 2t plus c, and that is y exponential t. So we're looking for y. So y becomes, this exponential t, we get rid of this, and this becomes exponential minus t, right?
Yeah.
Sine 2t minus 2 cos 2t plus c exponential minus t. Most of you actually got this right. That's impressive. Most of you got it right. So put up your hands if you got it correct. Great. So it means you're ready for next week's test. Of course, we're going to do exact next Monday. Exact is a little bit tricky. Yes, Nina. Please tell me I did not make a mistake.
I don't know. Actually, I won.
Did you get something different? You might be right.
Yeah, I did.
Yeah.
I could have done this one.
Let's see. Put up your hands if you get the same thing. So we'll know if all of us are making mistakes. We could be actually ty prime plus 2y. No, this is too simple. No. Should we try question 8 instead? Should we try question 8 or question 6? Which one? Question 6, put up your hands. Question 8. Okay, let's do question 8. So you try question 8 yourself. 1 plus t squared y prime. This is 4ty is 1 plus t squared minus 2. Okay. We can have our y prime plus 4ty over 1 plus t squared is 1 plus t squared negative 3. Do you agree? So that is, you divide through by 1 plus t squared. That's what I did. Okay, let me simplify it to make it easy. So what I did is, this is the question here. So if we have 1 plus t squared y prime plus 4ty is 1 plus t squared to the negative 2. So if we divide through by 1 plus t squared here, divided by 1 plus t squared, and divided by 1 plus t squared. So if we do that, this we cancel this, and we'll be left with y prime. This is this here, and this one goes to negative 1, that is negative 3. That's the first step. So our integrating factor u of t is exponential integral p of t, which is 4t over 1 plus t squared, 4t over 1 plus t squared dt. Okay, this is tricky. Did anyone try to do this integration? How? How do I do this integration? Does anyone know? Anyone? Yes?
U substitution?
U substitution here. I can say, let u be 1 plus t squared. Right? Is that what you did? There are several ways you can do this. There are so many ways you can do this. This is one of the ways. So if u is 1 plus t squared, du dt could be 2t, right? And that means dt is du over 2t. That's what it means. So if that's the case, let's substitute it here. So our u of t becomes exponential integral 4t divided by, instead of 1 plus t squared, you put u, because we already assumed that, right? then multiply by, instead of dt, you put du over 2t. Du over 2t. Right? So what that means is t can eliminate t. We're left with u of t is exponential integral 4 du. Actually, 2 here is 2. That will be 2 du over u. That's what it gives. So, what is integral 2 of, that's the same thing as 2 multiplied by 1 over u du. Because 2 is a constant. So if you do that, it becomes exponential 2 ln u. Because 1 over u is ln u from your table, right? So that's the same thing as exponential ln u square. Which is u square? Exponential ln u square is u square. Am I right? Did anyone get up to u square? Okay, great.
Wait, what happened to the 2?
This 2 goes here to be u square, yes. And recall that our u is 1 plus t squared. So it means our u of t will be 1 plus t squared squared. So if you get up to this value, put up your hands. Great. That is great. It means you're doing good. So now we found our integrating factor, which is 50% of the solution. So now let's solve. So our y multiplied by integrating factor is integral q of t, which is this guy here, integral 1 plus t squared minus 3 multiplied by 1 plus t squared 2 dt. Please, do you have questions? Okay, great. Let me solve here. For those of you that have solved it, if you feel like I missed a step, let me know. Like I said, I can also miss a step like you, especially when you're solving like this. Okay, so it becomes y 1 plus t square all square is integral. If you do this, this is negative 3 plus 2, that's negative 1, right? That would be integral 1 plus t squared to the negative 1 dt. There are several ways you can solve this. This one, there are so many ways you can do it. You can use the integral table if you want. You could use substitution method if you want. There are so many ways you can do this. Whichever way you decide to use is okay. So it can be integral 1 over 1 plus t squared dt. What number is it in the table if you want to use the table? Or you could use let u be 1 plus t squared. If you're using the integral table, what number it is? 8. Anyone? Number what? 8. Number 8. Let's see number 8. Can I borrow this, Nina? Okay. Number 8. Thanks for that. So the reason why I'm using this is because I wanted you to get familiarized with this table. That way you don't have to memorize anything and it becomes easier in the exam. That's why it's not as if we can't solve this normally. We can actually solve it. But if you use another method to solve it, let me know the method you use. So number 8 says that you have integral 1 over 1 plus x squared dx is tan inverse x. This is unique. So I have never seen this before, to be honest. So that's integral. Yes, I have never solved this question before. Yeah. So 1 over 1 plus t squared would be tan inverse t. Did anyone solve another way? Who solved another way? Okay. So we have y 1 plus t squared all square would be tan inverse t plus c. If you get it up to this point, I give it to you. That's impressive. So y would be tan inverse t over 1 plus t squared all square plus c over 1 plus t squared all square. If you get it up to this point, put up your hands. Let's see. we're going to stop here today. I'll look at this question again.